Hello everyone, I'm Orko and again I'm back with another interview question regarding BMath and BStat. So this problem is a counting problem and it's like a simple problem. But what happens is the solution is just a one line, okay? It's just a one line thing, but the thinking process is important, okay? So that's why these type of questions are asked in the interview, because you don't have to calculate a whole lot of things and come to the conclusion or something. Just the thinking matters, okay? And you can write down the answer in just one line. So let's without wasting time, let's get into the problem. So you have to make a sequence of length 8, okay, involving these integers 1 2 3 4 5 6 7 8. Now the condition is that now you can't repeat the integers, so that means you have to use all of them. But how to use them? There is a specific condition which states that at any given point in the integer, so suppose the number which is sitting at the 5th place, so that number should be greater than all the numbers before it, or should be smaller than all the numbers before it. So this not only for the 5th place, like for any place this should be true, okay? So I have an example for you, like 5 4 6 3 7 2 8 1. Now look at here, like whichever is the first number, it's trivially true because there is no number before it, okay? Whichever is the second integer here, for example 4, it's 5 is bigger than 4. Coming to 6, which is in the 3rd place, 5 as well as 4 which are smaller than 6. Coming to the 4th place, which is 3, so 5 4 6 all are greater than 3. Same for the 5th place, which is 7. So 5 4 6 3 are all smaller than 7. 2, again 5 4 6 3 7, all these integers are bigger than 2. 8, again all the numbers, because 8 is the max out of these, so all the numbers before it are less than 8, of course, and 1 is the minimum one, so all the numbers before that is greater than 1. So now you have to like form such sequences of length 8, and you have to come up with how many such sequences can you make. Now the thing is that we are not going to count like a layman. Even if you start counting like a layman, you have to form these sequences. But the difficulty is that with these conditions there will be so many cases, and you might miss some cases, you might miss some sequences, and you might end up at wrong count, okay? So yes, talking about the count, if you can make such a sequence, then the count is +1, okay? So that's the question, that how many such sequences can you make? How many such sequences with this condition can you make? So now how do we attack this problem? So before going into the solution, I would request you, those who have found this question interesting, so just pause the video and try out the problem on your own, okay? You can later on come back anytime and look at the solution, but at least you should give it a try on your own, okay? As I told, that the only thinking matters, no such heavy calculations or anything, just thinking matters here. So now coming to how do we attack the problem. So here one thing is that since while making a sequence, what do we think, that what will be the first term, second term, third term, and so on, right? Now here, if we think like that, the problem is that if we whatever we take as the first term, we have to make sure that whatever we put later on, so the criteria fulfills that at any stage that number, like all the numbers preceding that number, what we are putting at the kth place, so that all of them will be lesser than that, or all of them will be greater than that. So later on we might not have any problem, whatever we put it in the first place. Now you have to think how many such numbers we can put it in the first place, and then coming to the second, so suppose you have put one number, again in the second place, again the same thinking, like what number should I put, like later on I don't have any problem with the given condition. And so things gets complicated, okay? Here too many cases arises, and you don't get a definite way here. If you don't I have seen this, I mean when I also tried out this problem, I also faced the same thing. So just go and think like this. You'll see that too many complications are arising. Okay. So now, what's the other way? So the other way is that if you think from the backwards, okay, so since this sequence has a finite length of length 8, so let's talk about the very end, the 8th place. So the 8th place, you see that like whoever sits at the very end, all the numbers before that will be either greater than that number, or will be, all of them will be smaller than that number. So now I have only two numbers in this out of these integers from 1 to 8, which I can put it at the very end, that is either 1 or 8, because 8 if I take, then all the remaining numbers, because all the remaining numbers has to sit before that last number. Whoever sits at the very end, before that all the numbers, because I have to utilize all these integers. So suppose just for example, if I put 7 at the very end, so before that I will have to put 8 as well as 1, 2, 3, all the other integers. So what happens here is 8 is bigger than 7 and 1 is smaller than 7. So the condition violates, because if 7 sits at the very end, the condition violates. So here we know that only at the very end only 1 and 8 can sit. Okay, so whoever sits doesn't matter. So all we know is that at the very end, so let's take 8 gaps, 1, 2, 3, 4, 5, 6, 7, 8. So the last place we have two choices. Okay, 1 or 8. So 1 or 8. Whoever sits either 1 or 8 doesn't matter. So then we will go to the second last place, the 7th place. Okay, 7th place. Now out of the remaining numbers, okay, now forget about the very end. Whoever sits there, delete that number from this list, because you can't use that again. Now out of the remaining list, again the same condition and again the same thing, because now what is happening is that for the remaining part of the sequence, that's the end, like I'm talking about the remaining part. Okay, so that's the end number. So again the same condition, that number should be greater than all the numbers before it or less than all the numbers before it. Okay, so that means out of now the deleted set, like whoever sits 1 or 8, deleted. The rest of the integers, again whoever is the out of them, whoever is the max and mean, so those two only can sit at the 7th place. Okay, so again I have two choices, and if I keep on continuing, so this 8th place, 7th place, then 6th place will also have two choices, and so on and so forth. Okay, every time the same concept. But coming to the very first place, so you see that already 7 places have been filled up. Okay, now we only have one integer left. Okay, and obviously, I mean, in the first place it has to sit, there is no other option. So only for the first place, then we will be only left out with one integer, and so one choice. So finally, with the help of multiplication principle, because each choice for each of the two choices, for the 8th place I have two choices for the second 7th place. Okay, second last place, and again similarly for each of those choices for the second last place, I have two choices for the third last place, and so on and so forth. So using multiplication principle, we can say that the answer is 2 to the power 7. So we can make 2 to the power 7 such sequences where such conditions hold, that is at any given point in the sequence, all the numbers before that number are either smaller or greater than that number. Okay, so yes, now as you saw that the solution is just one line, but the thinking process is the main thing of this problem. Okay, so that's why like these type of problems are very common for the interview questions, and yeah. So I hope you have enjoyed the solution. So I'll be back with more such solutions, and yeah, thanks for watching. So keep watching and keep learning, and see you in the next one.